Topic today called financial maths, and we're going to look at something called present and future values, and we're going to take a look at it in the context of this example. Suppose I choose to pay you €100 now, or 115 guaranteed in 2 years, assuming you can invest risk-free at 5%. So, there is a choice here. I choose to pay you €100 now or €115 in 2 years. And you've got to decide which one is the better option. So the issue is, if I look at now, what's my options? Well, now I'm going to get given into my hand €100. I know that I can invest this €100 risk-free at 5% interest. So the interest is 5%. Now, the formulas we're going to be using are on page 30, and it clearly states on page 30 that if you're using these formulas, you must convert your interest rate into a decimal. I want to find out what the future value is of €100. So I'm going to be using the future value formula, and the future value formula, straight from the formula book, is the present value 1 plus I to the power of t, where t is the time period. Now, what do I know? I know that I is 1.05. Therefore, I now know that 1 plus I is equal to 1.05. I've read the question. The present value is €100. That's what I'm going to have in my hand now. And the time period over which this deal was on offer is a period of 2 years. So t is equal to 2. So now I put it into my formula. So the present value is 100, open bracket, 1.05 to the power of 2. Reach for a calculator, type all that in. You should be doing it as well, pausing the video and checking that what answer you get. And when I do this, I get a future value of €110.25. So if I take the €100 now, this is what I will get in 2 years' time. So let's look at the other offer. I had the choice of collecting the €100 now, or in 2 years' time receiving 150. And so in 2 years' time receiving 115. So which is the better offer? And of course, the better offer would have been to take, using this analysis, would be to take the 115 in 2 years' time. So the better offer would have been taking the 115. Now, there is another way, a new way of looking at this, and it's called looking at the present value. So it's done exactly the same way, except instead of looking at what you're going to get into your hand now, you actually look at what you're going to be guaranteed. You're looking at the guaranteed amount of money, what you're expecting to get into the future. So if you use the present value approach, you're looking at what they're hoping, what they're going to give you in the future in 2 years' time. So in 2 years' time, they're going to offer you €115. You know that the interest rate over that time period is 5%, which is 0.05, written as a decimal. And you know that 1 plus I is going to be equal to 1.05. So, and now what we're going to do is we're going to look at the present value formula in order to make the comparison. So we take the present value formula straight from the formula book, which is equal to the future value over 1 plus I all to the power of t. So we then substitute in our information. Well, the future value is 115. The interest 1 plus I should say, is 1.05, and the time period is 2 years. So now we press the fraction button on our calculator, put 115 on top, and we put 1.05 on the bottom. We raise that to the power of the bottom to the power of 2, and what we get coming out is the present value based on this deal is going to be worth 104 euros and 30839 cents. And if we want to write that down, it's going to be 104.31 cents. Now, so basically, based on their offer, in real terms, what is their offer worth now? Well, their offer worth now is 104. What was I offered now? Well, I was offered 100 now. So clearly, this is more than what I was going to be offered now. So therefore, once again, I can see the future cash deal is the one to opt for. So once again, by doing the present value, I've worked out the present value of 115 to be 104, which is bigger than the 100 on offer. So therefore, the 115, using this form of analysis, gives, as you'd expect it to give, the same answer. Okay, let's carry on to the next page, and where I've already set the work out for the first example. And let's take you through it. And what you see here is in 4 years' time, you are guaranteed 58,564. So in 4 years' time, you're guaranteed a future value of 58564. The discount rate, now this is just a fancy word for the interest rate, is 10%. So the interest rate is 10%, and remember, we have to convert that into a decimal. I've already taken the liberty to write down, because this is a calculate the present value of this sum of money. So I've written the formula in here, and because I've written the formula, I've noted I need 1 plus I. So I've worked out 1 plus I here, and 1 plus I is equal to, adding 1 to the answer above, is equal to 1.1. The time period was 4 years, so t is equal to 4. So I've put all that into the formula, and when I tap it into the calculator, I discover that the value, the present value of this sum of money is 40,000. So present value is basically a base level. It's a way of comparing what your money will be worth now in real terms. So what we're going to do now is going to see example 10.2. We're going to see this in a slightly more complicated example. We've got an investment opportunity arises where a person will receive a payment of 10,000 euros at the end of the next 3 years if they invest 25,000 now. So the growth over this period is 5%, and it says use the present value method to assess the suitability of this investment. So what we're looking at is, well, what are we getting? We're going to invest 25,000, and then we're going to get 10,000 at the end of year 1, 10,000 at the end of year 2, and 10,000 at the end of year 3. And what we want to find out is, was this investment worth it? Now, what is the investment? This is our baseline comparison. Our investment is 25,000. So what we're going to do is we're going to work out the present values of each of these 3 sums of money. If that present value, when we add them all up, is bigger than 25,000, then the investment was good. If we work out the present value of each of these 3 and we discover that it's less than 25,000, then the investment is bad. So we're using we're using present value in order to compare. So down here, I'm going to write down what the present value formula is from the formula book. And the present value form is equal to the future value over 1 plus I to the power of t. So what do we know? Well, this is a simple problem. We know that each future value is 10,000 euros. So the first thing is we know that each future value is in actual fact fixed at 10,000. Very handy. We know the interest rate is fixed over the period. It's fixed at 5%, and we write that as a decimal. It's 0.05. When we add 1 to it, get 1 plus I, we end up with 1.05. And the time period, unfortunately, is not fixed. The time period has 3 values. The first value is a value of 1. We have to bring this back 1 year to the present day in order to compare. The next value for time is from this sum of money, which is at the end of year 2, which means in order to compare it to the now, I have to bring it back 2 years. And then this one is handed out at the end of year 3. So in order to compare it to the 25,000, I have to bring it back 3 years. So I'm going to complete this formula to the best of my ability. Is the F fixed? Yes, it is. So I'm going to write 10,000. Is the 1 plus I fixed? Yes, it is. So I'm going to write 1.05. Is the T fixed? No, it varies. It has 3 values. So therefore, it's going to be just to the power of T. So I've now got my present value formula. Writing it up here is 10,000 over 1.05 to the power of T. So I'm now going to apply it to this situation where the value of T is equal to 1. So what's the present value going to be for 10,000 euros 1 year on? And it's going to be 10,000, using the formula above, over 1.05 to the power of 1, which I will work out in a few minutes. The present value of this one, but I've got to bring this one back 2 years. So in this formula, the value of T now becomes 2. So this becomes 10,000 over 1.05 to the power of 2. And then the third payment, payment number 3, use the formula. So the only thing that changes in this formula is still 10,000, it's still 1.05, but the value of T is now equal to 3. And what I've got to do is I've got to work out the total of these and compare it to 25,000. Now I've got a choice. I can work out each one separately and then type them in again to work out the total, or I can do it all in one go. So what I'm going to do is I'm going to type this all in one go and add the 3 fractions together as I go. So on my calculator now, I'm pressing the fraction button once, typing 10,000 on top, and on the bottom 1.05 raised to the power of 1. And then I'm going to move the arrow key on, put a plus symbol, and do fraction button. And once again, I'm going to have 10,000 on top, and on the bottom 1.05 raised to the power of 2. Then arrow forward, put a plus sign, and then a new fraction button, and I'm going to have 10,000 divided by 1.05 to the power of 3. And when I do that, I'm going to press equals, and I'm going to find out the total. I'd like you to pause the video at this stage and see if you can get the same total as me. When you've got your total, restart the video, and the total I've got is 27,232.480 0.029. And what I quickly see is that if I get these 3 payments of 10,000 and I bring them back to the present day in order to compare them to the 25,000, I see that it's worth more than the 25,000 I had in the present day. And therefore, because it's greater than the 25,000, it is a good investment. It's considered to be, in mathematical terms, a good investment. Okay, next thing is going on to the next example. And next example is a little bit like Dragon's Den. So if you look at this, someone at the beginning of the company starting, so at the very start, so time is 0, someone gives the company 50,000. Hence, cash flow is minus 50,000. At the end of year 1, they get another 10,000. At the end of year 2, the company's in profit and is paying out 15,000. And similarly in year 3, at the end of year 3, paying out 20,000. At the end of year 4, is paying out 35,000. Now, there's a set discount rate and interest rate over that time span, and it's been set at 5%. So what the venture capitalist wants to find out is, has he made money over this period? And the way he or she does that is by working out the present values of all these sums of money. And basically, if it is bigger than 0, then he's made money. If it's less than 0, he's lost money. If it's equal to 0, he's broken even. Okay then, so we're using present value in order to isolate this. Now, we need to be very, very, very careful about how we set this out. So everything is going to be brought back to the now. So what's happening now? What's happening? Well, at this moment in time now, the investor is investing 50,000. Okay. What about in 1 year time? Well, in 1 year's time, the investor is investing another 10,000. And in 2 years' time, they're going to gain 15,000. And in 3 years' time, they're going to gain 20,000. And then in 4 years' time, they're going to get 35,000. So what the entrepreneur is convincing L. Jordan, the venture capitalist, to invest. So in order for the venture capitalist to know whether it's worthwhile, he has to work out the present values of each of these sums of money. So if down the bottom, I'm now going to write down, well, what's the interest rate over this time period? Well, it's 5%. And if the interest rate over this time period is 5%, I need to write that as a decimal, so it's 0.05. I know that the present value formula uses 1 plus I within its formula, so it's going to be 1.05. I know that the formula, the present value formula, is equal to the future value over 1 plus I to the power of t. Now, are each of the future values fixed? And the answer is no, they're all different. So at this moment in time, I can't substitute for f. Is 1 plus I fixed? Yes, it is. It's 1.05. And is the time period fixed? No, because this is now, this is 1 year time, this is 2 years time, this is 3 years time, this is 4 years time. So therefore, that is not fixed. So now, I'm going to write down, well, what's the present value for this one? Well, that's simple because that is now. So the present value for this one, there is no work to do. It's minus 50,000. What's the present value for this one? Well, I'm going to quote the formula. The formula is future value over 1.05 to the power of t. But the future value on this line is minus 10,000, so I substitute that in. The interest rate is 1.05, and how many years do I have to bring this back in order to find out what it's worth now? And the answer is just 1 year, so it's 1.05 to the power of 1. The present value for this one, I don't have to write the formula out again, it's written above, is 15,000. So I put 15,000 in, and the interest rate is 1.05, but I'm bringing this one back 2 years to bring it into the now time. Let's bring it back 2 years. And then the present value for this one is going to be its future value, which is 20,000, divided by the interest, which is 1.05. That remains fixed. But because this is 3 years into the future, I'm having to bring it back 3 years to bring it back into the now. And then finally, the last one, the future value is 35,000. It's 4 years into the future. So to bring it back to its present value, I have to choose t to be equal to 4. So what I'm going to do now is I'm going to work out each one very carefully. At this point, you can pause the video and you can start working this out. I'm going to tap it into the calculator as quickly as I possibly can. Now, the first one is equal to, by my reckoning, minus 9,523.809. I think I might write that moving forward to just one decimal place. Okay, let's do the next one, which is 15,000 over 1.05 to the power of 2. So it's minus 15,000 over 1.05 to the power of 2, and that's going to be equal to minus 13,000 minus 13,605.442. And now we're going to press the replay button again, and this time I think I made a mistake. Sorry, that's not minus 15,000, it's plus 15, so it's going to be plus 13,605. Sorry about that. The next one is 20,000, so put 20,000 into the calculator over 1.05 to the power of 3, and that comes to 17,276. 17,276.751. Keeping it simple. And then the last one is 35,000 over 1.05 to the power of 4, and that comes to 28,794.58. Now what we have to do, and don't forget there's also minus 50,000 up there in the left-hand corner. What you have to do now, again, I'm going to give you time to put this into the calculator and work it out, is you have to put that into the calculator and decide whether, add them up, whether the investment was worth it by comparing it to 0. So when we put this into the calculator, by all means, as I said, pause the video. What you get coming out at the other end to 2 decimal places is 152.97. Now on the maths course, because that's above 0, it's considered to be a good investment. But to be totally honest with you, because it's bigger than 0, so they've made money on it. Over the 4-year period, they've made 153 euros roughly. But really, in real life, is that a good return for the money? I think not. But for the exam, we say it is. Now, I don't know if you noticed when we started this page, there are questions at the top which I want you to tackle before you come back into school next lesson. Okay, thank you.